Hello and welcome. Today we will be discussing how to solve systems of linear equations using substitution. Now when we solve systems of linear equations, there are three different methods we can use. We can either use substitution, elimination, or graphing. But as I previously mentioned, we will be using substitution. So let's get into it. Looking at this example I have here, we have x plus y equals 5 and 2x minus y equal 1. These together make a system. We are looking for a solution that satisfies both of these equations for both x and y. So if I plug a value in for x, it'll make my first statement true, and as well for y, and same for the second. If I plug a value in for x and y, it'll make that statement true. So in order to find those solutions using substitution, what we need to do is start with one of our equations. It doesn't matter which one we pick, but typically we want to choose one that already has a variable isolated in some manner, where it doesn't have any numbers attached. So looking at this first equation here, both x and y are already isolated in terms of numbers, and they're both positive terms, which is also good. So I'm going to start with this equation of x plus y equals 5. So looking at this equation of x plus y equals 5, I need to isolate one of my variables in order to solve for it, and that is my whole goal here. So I can choose either x or y, and what I mean by isolate, I mean get it by itself on one side of the equal sign. So in order to isolate one of these, I'm going to use the inverse operation, which means I will be using the opposite of whatever is being represented. In this case, let's solve for x. So let's isolate x by using the inverse operation of a positive y. The opposite or inverse of adding is subtracting, so I will be subtracting y from here. That'll remove this y, making it 0. But what I do to one side of my equal sign, I have to maintain the balance of my equation here, so I have to do to the other side of the equal sign here. In doing so, I'm left with only x on my left side, and on my right side, 5 and negative y cannot be combined, so I'm left with just 5 minus y. If you notice here, now I have a solution for x. It says x is equal to 5 minus y. That means I can go into the second equation here and plug that in for x and solve for my other variable, y. So let's do that. So the equation I have is 2x minus y equals 1. But I've already solved partially for x. I haven't gotten a whole entire solution for x, but I've gotten a partial solution. So I'm going to go ahead and plug that in for my value of x. That's going to be 2, and this is 2 times x, so it's going to be 2 times whatever that value of x was, which was 5 minus y. Do not take the x with it. That x is being replaced. That's what we're replacing. We're saying x has a value now. It has a value of 5 minus y. So this is going to be the distributive property that's going to be happening here. But we still have to remember we have minus y equals 1. So now we can start solving. 2 times 5 and 2 times negative y using our distributive property. This gives me 10 minus 2y. Minus y equals 1. And we're getting closer to solving. Continue to simplify. 10 minus 2y minus y takes me to a negative 3y equals 1. And then I'm going to use my inverse properties, or inverse operation here, to move this 10 over to the other side. So I'm going to subtract 10 here, but what I do to one side of an equal sign, I must do to the other. So I will be left with negative 3y equals 1 minus 10 will take me to negative 9. I have one last step I need to do. I need to do the inverse operation of multiplication, which is division. So I'm going to divide negative 3 here. And in doing so, that's going to allow me to isolate my variable and leave me with just y equals. And negative 3 goes into negative 9, a positive 3 times. So now I have a solution for y. I know that y is equal to 3. But remember, we did not solve for x. We had a partial solution for x, which was 5 minus y. So I'm going to take that solution for y, and I'm going to plug it into my equation of x here. X equals 5 minus y. Well, y we said was 3, so that means x is equal to 2. So my solution set would be 2, 3. And both of these values, if plugged in, would satisfy both of these equations and make them true. And that is how we solve a system of linear equations using substitution.